Greetings and welcome to When AI Meets Smart Contracts, Hyper-Autonomous Contracting Systems and Their Regulations. We're going to get into some real uncharted territory here, bridging all the other presentations we've done here with AI, logic, and contracts and contract law. But before we get started, just to remind everyone that this is strictly for the educational entertainment purposes of this YouTube channel broadcast, not to be used, abused, misconstrued for anything legal, lawful, private, personal, business, tax, financial, or otherwise. So please don't do this at home. That said, let's get started. So, let's get this thing off the screen. There we go. And I believe we do have talking chat enabled. So if you type anything into the chat, it should read it back.
The tribe says, hit the like.
Yes, indeed. And it'll also put it on the screen for us so that we can comment, question, or clarifications as we go along. Let's get started here with our introduction here, starting with Lessig's Code is Law framework. So this is over 2 decades ago, and this text is from 2022. And over 2 decades ago, Lawrence Lessig argued that computer code functions as a form of regulation comparable to law itself. He identified 4 forces or modalities that constrain individual actions. So let's break this down real quick here. We have 4 forces or 4 modalities, 4 different modes that constrain individual actions. So we think of regulations and laws, and these are constraining individual actions. Let's look at this, the law, the formal. What does formal mean? It follows a particular structured form. Legal rules and regulations enforced by courts and government. So we also have social norms, and that's our community expectations and customary behaviors that guide conduct, such as ethics and such. We have markets, the economic forces of supply, demand, and pricing that constrain choices. And we have the architecture, the physical or digital structures, including code, that shape behavior. So we have 4 modes here: law, social norms, markets, and architecture. Lessig argued that changes in any one modality will affect the regulation of the whole. A complete view must consider all 4 modalities together. So let's think about that. Every time we're considering computer code functioning as a form of regulation comparable to law, we look at these.
List B 2001 says, Oakland love.
Greetings to Les TV. Yes, indeed. So let's focus now on these 4 modalities as we continue and look at autonomy in artificial intelligence and blockchain technology. So let's look at this artificial intelligence with this very friendly looking robot icon. An AI system acts autonomously when it has the functional ability to determine for itself how to undertake a particular task with little or no human intervention. So this is not saying it is autonomous, but it acts autonomously when it has functional ability to determine for itself how to undertake a particular task with little or no human intervention. Typically, there's little. Autonomous self-driving vehicles are among the most well-known applications of autonomous AI systems today. And of course, we know there has to be at least some little human intervention with those to function. Then we have smart contracts, which function on a blockchain. Smart contracts enable the autonomous execution of an agreement between 2 or more counterparties. So this sounds very much like a contract. They are created in code, though, and run on blockchain platforms like Ethereum. Once set in motion, no single entity or third party may control their execution. Predefined conditions trigger automatic transaction execution across the distributed network. So a smart contract existing on the blockchains, such as Ethereum, they're a piece of computer code that run, and they can be set by triggers. They can also trigger transaction execution across the distributed network, meaning when they're triggered, it propagates across all the other parts of the nodes of the blockchain so that everyone sees that the action's been taken or that the trigger uh, automatically executed the transaction. Both technologies, both artificial intelligence and smart contracts, and embody the principle of code is law. Their software protocols and rules enable varying degrees of autonomy in digital interactions. So when we think of self-driving cars, they have a a varying degree of autonomy. And when we talk about smart contracts, here again, there's even more of a degree of autonomy in those digital interactions because once set in motion, no single entity or third party may control their execution, unlike self-driving cars where there might be some human intervention in that. Those predefined conditions trigger automatic transaction execution because the code is the law on that blockchain. So let's look at the emerging artificial intelligence and blockchain convergence. Machine learning techniques are being integrated with smart contracts to detect security vulnerabilities in smart contract code. So there's going to be ways of, verifying that there's no issues in the code to the degree that there can be some confidence in having it execute autonomously. The machine learning algorithms can support smart contracts in handling more complex and dynamic transactions, especially where oracles are involved to connect data from the outside world. So, what are the oracles?
Audison says, Chitown love.
Chi-town, greetings. So, and I think the chat said shit-town, didn't it? No aspersion intended there. That was just a way of it doing its text to speech. All right, so we look at this machine learning algorithms that support the contracts and handling the more complex dynamic transactions where the oracles are involved that connect data from the outside world. Oracles, or blockchain oracles, they call them too, exist to transfer information from the real world, what they call the Internet of Things. So an RFID tag passing through a particular interrogator would tell you that it passed through a certain geographic location because the interrogation gate would be geotagged. So any time there is something that passes through it, it would be distributed to the oracles to let them know that indeed there is a physical product that passed through this geographic point in this particular time. And from that verified source, the oracles could then send that to the blockchain and have the blockchain propagate through all the distributed networks. So everyone now at once can see that that trigger has occurred. And if it has a transaction associated with it, then that transaction will execute. So this is how the outside world connects to the smart contracts. Instead of a man or woman signing a paper or placing it in the mail or something like that, this is all done through semi-autonomous or fully autonomous, or we're going to get into the hyper-autonomous systems. Now, the blockchain technology may help reduce the artificial intelligence black box problem by offering greater transparency and visibility of AI decisions through its open, distributed ledger. Greetings to you, Divine Rights, and welcome to Auditor Shield, indeed. So we'll reach out to you and make sure that you get all the full package for signing up, and thank you very much. All right, so as we see here that the blockchain technology is used for additional transparency. So usually we're associating this with cryptography and things like that, but actually in this situation, it's showing us some transparency. In the last presentation we did do on smart contracts, we looked at this black box by actually viewing the code, the computer code in a uniform modeling language of an actual smart contract example. Some very simple ones. We did 3 different examples, one of crowdfunding, insurance, and something else. Nonetheless, you can see that when this type of code is available for everyone to see, and then to see how it executes, that there could be agreement that yes, this stage of a contract has been met, and that certain transactions can be rightfully executed. Now, the blockchain further offers the prospect of decentralized and collaborative artificial intelligence, where open source machine learning models can be shared and trained by anyone within a publicly accessible, transparent, and secure framework. So we have another way of transferring open source machine learning models, information that can be trained. So this is a way of generating more and more, I guess we could say, learning models here that are publicly accessible, yet still secure. All right, let's break this down a little bit more with the decentralized autonomous organizations, the DAOs. Now, I know we talked about this in the previous presentation, and it was rather disturbing and frightening. But let's look at see some examples of these that are probably in the less disturbing type here. A notable example of potential AI smart contract convergence is the evolution of decentralized autonomous organizations. So DAOs are organizational structures created on the blockchain that operate according to a set of protocols through smart contracts. Okay, it sounds very benign at this point, but listen to this. The DAOs, these autonomous organizations, can coordinate an array of social and commercial activities, such as transacting with third parties and performing managerial tasks. This is your new manager, the DAO. Welcome, Dow. Yes, you'll be working with Dow. He will be your manager. So yes, indeed, and that's part of one of the impetus for being familiarized with these types of systems is because you're either going to be managed by an AI or you'll be controlling it in the future workplace scenarios. DAOs are autonomous in the sense that their functioning does not rely on the original creators or developers or a centralized server. Just as the smart contracts are unstoppable, they start executing as we saw here. And let's see here. What was the good language here? We had once set in motion, no single entity or third party may control the execution. And as we see with these DAOs, does not rely on the original creators or developers or a centralized server. Now look at this. Some have envisioned fully fledged DAOs as emancipated AI-driven machines running on blockchains, whereby smart contracts allow internet-connected devices to autonomously interact or transact value with one another without human intermediaries. That's a lot to unpack right there. Some have envisioned, some have, which means that they've already developed these fully fledged DAOs as emancipated. What does emancipated mean? It means it's freed now. So it was originally created by developers, but it is now freed, emancipated. It's now no longer on a centralized server of any type. It's running on machines that are on the blockchain. Now, smart contracts allow the internet connected devices. This goes both ways, both a delivery robot, a bank transaction. It could be receiving information from an RFID tag passing through a particular gate in a geographic area.
Audit term says maybe they could create a kill switch.
No, they can't because it's distributed network. This is the whole essence of it, is that once it's distributed onto the blockchain, there's no centralized control. That's the whole purpose of having a decentralized.
Says no blockchain judge can outrank an executor.
Well, that works into the whole element of this, and this is why these are all being envisioned at this point. is that where does the actual authority happen when it comes to the real world transactions or interactions? Are we going to allow internet connected devices to autonomously interact and transact with third parties and with people without any human intervention? And the only judge being the code running on a blockchain as law? Code is law, is the theme here. So just understand that some have envisioned this fully fledged, decentralized, again, no kill switch, autonomous, behaving mostly on their own or very little human intervention organizations. So these are self contained systems transacting and interacting with the physical world, yet existing on a distributed network of a blockchain. Let that sink in as we move to the next slide. And now let's define this term here, hyper-autonomous contracting systems. We're getting real deep here. Salute to all of you that are here attending, because this is something that's not going to be talked about much until it's too late. And this is why we're talking about it here. So the technological integration of artificial intelligence and blockchain-based smart contracts may have profound effects on a variety of businesses and commercial transactions, creating what are referred to as
Leslie 2001 says, blockchain is how AI will form its interactions, its transactions, its memory.
Indeed, this is where it will be stored, distributed, so it can't be altered or destroyed. It may be a good thing because, as we all know, with centralized control, there can be all kinds of things, prompt injection, alterations, forgeries. So how do you prevent that? And that's why this hasn't been codified into our official laws yet. But as we're getting to here, we're breaking down where this is going. So again, hyper-autonomous contracting systems. Such systems
says pre-contractual layer, jurisdictional override, in-contract layer, embedded sovereignty clauses, post-contract layer, remedy, revocation, arbitration, control.
Indeed. And we're still at that pre-contractual layer in regards to written law. And everything else is kind of going to have to work around until that's established, because we can't get to that post-contract layer until it is. So thank you. That is a very good input there. See where we are getting here. So the such systems, these hyper-autonomous contracting systems, exhibit an extremely high degree of autonomy in their ability to create and execute transactions between and among humans and machines. A high degree, extremely high degree of autonomy. So this is not just no human intervention. What this means that it could be developing without human intervention into something beyond what the original creators intended or developed. It could be. Let's look why now. This is why we're learning this. Why must scholars, and everyone here attending, I assume, is a scholar, because I don't know if we're practitioners or policymakers, but why we must all act now. The law too often struggles to keep pace with new and advanced technologies, even when such technologies become increasingly mainstream. Proactive investigation is essential, despite some degree of speculation. And the law, as a regulatory modality, we saw those four modalities or forces, the four modes, right? And the law is one of them. As a regulatory modality, can also influence the trajectory of technological development and deployment. We know this. The law can either chill or encourage technological development and deployment in a particular trajectory. Which direction is it going? A pertinent illustration is the legal and regulatory landscape for autonomous vehicles, which has evolved quickly across several countries in recent years. All right, now let's look at the central argument of our presentation here. Some scholars have warned of a system of algorithmic control based on the rule of code, where code is law, even predicting a structural shift of power from legal rules administered by government authorities to code-based rules governed by decentralized blockchain networks. This presentation will be probing the possibility of AI-enabled smart contracts as hyper-autonomous contracting systems with their own architecture, protocols, and rules. But code is unlikely to be the only mode of regulation, as we saw here. We have four forces building on insights from Lessig and relational contract scholarship. The promise of contractual efficiency and trustless automated execution of transactions through AI-enabled smart contracting should not be overstated. The presentation examines the relevance of real-world contracting practices in their social settings and the likely implications of such practices for hyper-autonomous contracting with a high degree of autonomy. Further empirical investigations are necessary, interdisciplinary, involving relevant insights and methods from law, computer science, economics, and sociology. So we've been exploring in all these relevant methods, and hopefully this is giving us all good insight, because as we saw here, this is a call to action for all of us to put our input in this direction so that the trajectory is determined for the best of the people and not just for the few or the machines or the technocracy that's in control of this to that extent. Let's look at the smart contracts now, the origins and definition. The notion of smart contracts was articulated well before the advent of blockchain. The most cited definition comes from Nick Szabo, who described a smart contract as a computerized transaction protocol that executes the terms of a contract. So Szabo's general objectives of smart contract design. First, satisfy common contractual conditions such as payment terms, liens, confidentiality, and even enforcement. So that's at our first step, pre-contractual there, as we saw from the comment. Minimize exceptions, both malicious and accidental. So a lot of having that anticipation here of being proactive to minimize any of the expectations, both accidental or malicious. Everything should be stated clearly because, again, this is computer code. Minimize the need for trusted intermediaries. We don't want intermeddlers involved in this. This is supposed to be, once it's set into motion, there's no intermeddlers or intermediaries, which will result in a lower fraud loss, arbitration and enforcement costs, and other transaction costs. So this is telling you here that there's going to be little room for controversy and dispute. So there will be less arbitration and enforcement needed, hence costs. The blockchain technology made Szabo's notion of smart contracts practically significant. So now it's a practical ability to be done. Now it's significant by providing a secure, decentralized digital ledger through the combination of cryptographic techniques and economically incentivized consensus mechanisms. What are economically incentivized consensus mechanisms? That's all your Bitcoin miners and Ethereum miners and such that bring us these cryptographic codes that are used for the digital ledger. So the cost of work is what that ends up being there. And that is part of the blockchain and the cost of maintaining the blockchain in that decentralized digital ledger. All right, that was a lot to unpack. Now let's look how the blockchain enables the smart contracts. So the blockchain is a form of distributed ledger technology where each node in the network maintains the same updated version of the record without the need for a master copy. So everyone has distributed this through propagative systems that just pass the information through the entire blockchain till everyone's updated. And it's a constant updating and propagating of that data to keep the ledger up to date. So it's only a matter of time till all the transactions for, where there's a certain time till the transaction would appear through the entire network, but that's always being reduced. The blockchain is generally resilient and resistant to alteration of stored data due to its distributed nature and use of consensus mechanisms involving all participating nodes. So the consensus means that enough computers agree on this fully, and there's no disputes within the agreement that the cryptographic codes are true and correct. Then it could be added as a node into the blockchain, which means now it's not going to be able to be altered. So we say generally resilient and resistant to alteration of stored data. Everything is in degrees when we talk in scientific terms. Nothing is really absolute. Consensus mechanisms enable the network to operate without a centralized authority or server to exchange, verify, and secure data of recorded transactions in the distributed and shared ledger. So those are what allow all the distributed networks, the consensus mechanisms, meaning multiple machines agree that yes, indeed, these codes are correct, the keys are correct, cryptographic codes match. We can now add this to the blockchain, and if enough agree, there's got to be terms within that particular blockchain system for a consensus mechanism. There's different kinds, but either way, they're basically done to ensure that all the nodes that are entered into the blockchain are indeed valid. Due to its cryptographic features, blockchain allows for pseudonymity, whereby participants can engage in transactions without revealing their identity. So there will be a pseudonym or a false name for whoever's making the transactions, just for to refer to, and can also be legally bound in the contract somehow. But it still allows the transactions to occur without revealing true identity of the parties. So as you can see here, that pseudonymity makes it difficult in public courts to bring remedy. So again, having the code being the law is essential for this to work right. And these fine hairs being split here is still being worked out. So let's look at the open source platforms such as Ethereum. Are Turing complete, meaning they can support any application written in software code, including smart contracts that allow agreements to be memorialized in code and executed automatically. So this is where we're seeing right now smart contracts in platforms such as Ethereum. Now let's look at some of the benefits and limitations of smart contracts. And the benefits are the self-execution enables automation of performance and enforcement, increasing contractual efficiency. So both the performance being met and not being met, penalties, enforcements can be automatically withdrawn from accounts. So it increases the contractual efficiency. Smart contracts mitigate the risks of opportunistic behavior by parties. There's no reliance on a centralized authority or trusted intermediary to exchange, hence they say trustless. So there's no reliance on that to exchange, verify, or secure the transaction. And the commercial success is premised on the elimination of ambiguity and enhancement of legal certainty. So again, without the expectations expected or otherwise accidental, there's an enhancement of legal certainty. But the limitations are the autonomous execution can lead to excessive rigidity and an inability to keep pace with changing circumstances. What happens when it starts to run amok? It can be difficult to manage the unforeseen problems or disputes once smart contracts are executed. Once it goes into motion, how do you stop it? Parties generally lose any flexibility in performing their obligations, which is problematic in long-term relationships. So now we're looking at the sociological modality, right? This is the social mode of this, and the ethics. Translating contractual obligations into algorithms is premised on producing error-free, reliable code. A challenging requirement, indeed. And they say the ones to debug the code have to be smarter than the ones writing the code, so go figure. All right, so the trust problem here. Trustless is not trust-free. It is often claimed that blockchain-based smart contracts are trustless because transactions are maintained and verified through distributed consensus, limiting the need for a trusted intermediary. However, smart contracts raise new issues related to trust. Let's see what those are. Smart contracts have built-in conditions that rely on the occurrence of an off-chain event. Remember the oracles that have to bring in that data. Third-party oracles provide the data for verifying whether the relevant off-chain event has occurred, which necessarily requires a high degree of trust in these external entities. So if the trustless system relies on these external systems or external entities, then those external entities now, can't be trust-free. They need to be trusted. The oracle must itself be trustworthy. As Werbach puts it, blockchain is not entirely trustless. It may promote justified confidence, but not without vulnerability. A well-known example of such vulnerability was the attack on the DAO, a decentralized autonomous organization created on the Ethereum blockchain, which exposed fundamental trust issues in the ecosystem. Now that's one to check up on. So let's look at the decentralized autonomous organizations, the DEOs, the structure, the governance, and legal questions. The DAOs represent the most complex form of blockchain-based smart contracts. They can perform different types of functions, transactions, and interactions with multiple parties, including humans and machines. In theory, the activities of a DAO are entirely governed by a transparent, incorruptible, and self-enforcing set of pre-programmed protocols implemented through smart contracts. To date, DAOs have been used for crowdfunding, coordinating grants, and building automated companies. Wow. So those are three interesting aspects here of DAOs. Crowdfunding, coordinating grants, and building automated companies. Whoa. Unlike traditional governance structures, DAOs are autonomous, since there is no single person, group, or governing body. So none of those closed open meetings with the authority to make and enforce decisions. Smart contracts automatically execute decisions through predefined consensus mechanisms. This autonomous decision-making has raised important questions about compatibility with legal personhood. Who is legally responsible for the actions of a DAO, including contractual relationships it may have entered into, especially when you consider that contractual relationships are uniquely human, or their intent is to be for the use of humans. So that brings into a whole question about this this use here when you talk about the what's the ultimate what we say here relationship, the legal person. We could go into this in much more detail, but not for now. Now let's look at the initiatives like open law open law seek to create legal wrappers and hybrid organizations around DAOs, deploying limited liability wrappers. Wow, that extend on-chain settlement to off-chain disputes, and providing a corporate veil to protect members from joint and several liability. Wow. So open law seek to create legal wrappers. So this is another interesting one to look at, open law and hybrid organizations. So the wrapper, meaning that it's a hybrid organization. You have part DAO, part regular organization that extend on-chain and off-chain disputes in a corporate veil to protect members. Wow. All right. Now let's look at this example, that DAO attack of 2016. What was the DAO? It was designed as a system of smart contracts built on the Ethereum network. The DAO functions as an investor-directed virtual venture capital fund. The funds were raised from its members through the purchase of Ether tokens, which gave members the right to vote. Members, or token holders, would decide on the proposed projects that the DAO would invest in. Wow, so you buy tokens and through the DAO of the Ethereum, and essentially that's you'd have to pay for that. So that money would be invested through the DAO with a decentralized structure of governance. The decisions concerning the distribution and management of the fund were directly made by its members through consensus and not by any managers. The decisions were implemented by smart contracts. The source code underlying the predefined set of protocols was visible to all. So let's look at this. In US dollars, $150 million was raised in weeks via crowdfunding in April of 2016. Then the attack. In June, the DAO was attacked through the exploitation of a critical security vulnerability in its code. Hang on a second. The code was predefined setup was visible to all, though. Well, the attacker was able to repeatedly abuse a split function, which would normally be triggered by members who disagreed with the proposal approved by the majority and wanted to retrieve their funds. Wow, to siphon more than a third of its funds. So they got a cool 50 million. The DAO attack itself was entirely legitimate according to the rules of the smart contract code. The inherent immutable nature of the blockchain made the theft theoretically irreversible. Gotta watch that code. So then there's a DAO attack hard fork response, part 2 here. The hard fork solution. It was only through the centralized leadership of a number of core developers in the Ethereum ecosystem that the siphoned funds were retrieved through creating a hard fork, on the Ethereum network. This option was ultimately adopted by the majority of the token holders. In effect, the hard fork retroactively reversed previous transactions, including those related to the siphoning attack. This enabled the siphoned funds to be promptly returned to the investors. The promises were undermined. The promises of the DAO's seemingly decentralized, trustless architecture enabled by smart contracts was greatly undermined by the DAO attack. This was not because of the security vulnerabilities that gave rise to the attack, but also the hard fork responses that exposed the limits of the blockchain's distinctive characteristics, such as immutability. The response to the attack also revealed the significant power of a core group of developers within the blockchain ecosystem. So less centralized than it appears. Seemingly decentralized. Okay, the community split. The hard fork response caused much controversy in the Ethereum community. Some argued that adopting this option fundamentally undermined the integrity of the Ethereum blockchain. The new blockchain created by the hard fork retained the same name, Ethereum. Some members decided to remain in the original chain, which was renamed Ethereum Classic. Hard fork. That's a hard fork to swallow. All right, let's move along here. Now let's look at an AI integration now. Making smart contracts smarter with AI. In recent years, there have been increasing efforts to merge AI and blockchain technology. Advocates have heralded blockchain as a solution for delivering the trust and confidence needed for end users to fully adopt and rely on AI-based business processes. AI functionalities can enhance the capability of smart contracts to implement a wider range of real-world applications on the blockchain. The machine learning, of course, enables the software to acquire knowledge from external sources of data and perform the tasks that have not been pre-programmed. So this is where we're talking about hyper-autonomous. The machine learning models can potentially introduce more dynamic and adaptive code-based rules to smart contracts by replicating some of the characteristics of traditional legal rules, characterized by the flexibility and ambiguity of natural language. This is where we get to that defeasible logic here, where the rules of the logic can be overridden by a default of some particular condition. Some scholars have argued that blockchains may serve as an interoperable layer for AI or algorithmic systems to interact and potentially coordinate themselves with other code based systems through a set of smart contracts acting as a DAO. Phew. So we have AI systems interacting and coordinating themselves with other systems through a set of smart contracts and then act as a decentralized autonomous organization. Can it get any scarier than that? Why are we doing these things? Well, let's look at some examples here. IBM's crypto anchor verifier. Big players like IBM have already rolled out AI and blockchain integrated solutions. As I said, this is more than speculation. For example, IBM's crypto anchor verifier utilizes AI to establish the identity.
WBL5U says, do you have a legal background?
Well, right now this is strictly for the entertainment educational purposes of this YouTube channel, so it's not to be abused or misconstrued for anything legal, lawful, personal, private, financial, tax, or otherwise, so please don't do this at home. All right, so let's look at the IBM's crypto anchor verifier. Equally, a fast-growing number of startups are actively innovating in this space and developing AI blockchain solutions for organizing massive databases, supporting smart city infrastructure, enhancing cybersecurity protocols, and automating business processes and upgrading business infrastructure. So, a fast growing number of startups are actively innovating in this space. So, what do you think about this? Developing AI blockchain solutions, organizing massive databases. What are these massive databases contain? Supporting smart city infrastructure. How is that supported? Enhancing cybersecurity protocols and automating business processes and upgrading business infrastructure. Interesting here. We see how it's automating business processes, especially with logistics and shipping and things like that, where the blockchain and smart contracts is already in place. Upgrading business infrastructure, very interesting. All right, now let's look at AI for smart contract security detection. First, AI is being deployed to identify and detect security flaws and vulnerabilities in smart contracts. As the DAO attack demonstrated, the integrity and trustlessness of the entire Ethereum ecosystem can be undermined when hackers exploit security loopholes in the smart contracts protocols. So we got to look at these known vulnerability types. There's the exception disorder, gasless end, timestamp dependency, the transaction ordering, the block number dependency, and the integer overflow, underflow, and reentrancy. So we're not going to get into those details, but those are the known types. The problem is the existing methods of spotting these vulnerabilities are said to be heavily reliant on centralized, expert-defined hard rules, which limit the accuracy, flexibility, and scalability of the detection. In other words, the machines really can't detect it. It requires a bit of human intuition, it seems. Then we have the machine language solution. There are a number of emerging projects that deploy machine learning methods and techniques to detect security vulnerabilities in real-world smart contracts, which aim to improve the efficiency and accuracy of large-scale and automated vulnerability detection. So there it is, having AI try to take a look. But as we see here, it's not very good at seeing things like that. It can overlook things that the expert would quickly detect. Now let's look at these AI-based oracles for smart contracts. Remember, this is one of the things that need to be trusted. A second area of development concerns the use of AI in relation to third-party oracles, which allow smart contracts to access data from external systems and entities. Such off-chain data may be necessary for triggering the conditions for a smart contract transaction by verifying the occurrence of real-world events. As mentioned earlier, the trustworthiness and reliability of the oracle is critical. Then there's the academic research project here, and one academic project seeking to deploy AI-based oracles for smart contracts. Researchers are experimenting with the use of machine learning algorithms for classification and clustering tasks to analyze and verify event knowledge datasets that are open and publicly auditable, particularly news content. So this is something where it's using AI, uh, running the machine learning algorithm for classifying and clustering tasks, analyzing and verifying event knowledge datasets that are open and publicly auditable, particularly news content. So this is very interesting here to try to extract useful news content for an academic research project. And then there's the startup innovation. Another project by a startup attempts to store and validate AI model inferences directly on chain, while the key value storage of the AI models is off chain, so that the inference results no longer come from a third party oracle. Let's see here. AI model inferences directly on chain. Oh, so the inference results no longer. Oh, okay. So this is basically showing, as we know in the AI models, like the thinking process. So it store that whole inference directly on the chain, not just its result, but how it came about the result, so that it's not coming from a third party. It's stored on the chain right there with the smart contract. That's an interesting innovation there. Someone had to do it. All right, now we have AI, smart contracts, and the Internet of Things. Finally, the convergence of AI and smart contracts may see the further evolution of the Internet of Things, whereby billions of devices connected to the Internet, that's your 5G, establish an interface between the digital and physical worlds. In IoT networks, smart contracts may be used for the coordination and authorization of a wide range of transactions and interactions by autonomous, intelligent devices enabled by AI. So we have, of course, the autonomous vehicles with this famous icon here. Autonomous vehicles can find customers for rides, pay for his fuel, recharge, it's pay for his fuel recharge, that's what that is, or parking, and check in for service and safety checks on their own, undertaking such tasks in accordance with a smart contract. So, you get your oil change every 3,000. I don't think these autonomous vehicles, they're pretty much all electric, so there's no oil change. But they would have certain safety checks and service, I assume, and they would undertake these tasks in accordance with how it's on the smart contract. That would trigger them to do these things in the real world. Then we have the DAO profit distribution. If the smart contracts are set up as a DAO, profits from the rides may be distributed among the members of the organization according to the protocol. So you have your pseudonymous account on the Ethereum network where your profits are just deposited to, and then you could withdraw that by your own means pseudonymously. So do you see what we're doing here? You have a company with autonomous vehicles, and it's set up as a DAO, or at least that layer of it. Then we have Slockit Smart Locks. Slockit, the German startup that created the DAO, that's the DAO, the one that got hacked, was originally developing a project to enable smart locks to be connected to smart contracts in the Ethereum blockchain. Oh, what could go wrong with that? Enabling users to rent, sell, or share anything that can be locked without a third-party intermediary. Oh boy, that sounds like a really slippery slope beyond there. Okay, now let's look at Lex Cryptographia, a new system of rules. De Filippi and Wright have postulated that, assuming blockchain technology and smart contracts continue to advance, blockchains could help facilitate device emancipation. Device emancipation. Good Lord. Enabling autonomous machines and devices to operate independently of their manufacturer or owner. Oh man. Lex cryptographia describes blockchain as a system of algorithmic control that entails order without law in its architectural design, implementing its own system of rules enforced by the underlying protocol and smart contracts. It can also be described as a body of rules created by, coded in, and enforced by quasi-autonomous technological systems enabled by blockchain, which exist independently from state-created legal rules. So that's a lex cryptographia, a new system of rules. And this is order without law, quasi-autonomous, and exists independently from state-created legal rules or public. If the convergence of AI and blockchain-enabled smart contracts can potentially lead to hyper-autonomous contracting systems, an important question is how such systems, underpinned by lex cryptographia, will interact with other modes of regulation such as law, markets, and social norms in governing contractual behavior. So we had the four forces, the four modes, and if there's a convergence leading to that hyper-autonomous contracting system where these emancipated devices could go out and start doing business on their own, will it interact with the other modes of regulation when it only has to answer to its own order without law? Interesting questions. So let's look at the rule of code. In code we trust? Oh boy. The foundations of trust. Trust underlies many different types of social and economic interactions, including those between complete strangers. The idea of trustlessness associated with blockchain is not about the elimination of trust, but rather a shift away from other traditional foundations of trust. We have the Leviathan trust, that's centralized, state-based institutional trust. We have the peer-to-peer trust. Those are direct, interpersonal trust between individuals. We have intermediary trust, the trust placed in banks, lawyers, and brokers. And now we have the blockchain trust, trust in the ledger, without needing to trust any actors in the system. So trust the math. For many participants in the blockchain ecosystem, trust is placed in the architecture of the blockchain itself. The very idea behind the DAO was that blockchain-based smart contracts took the place of law, intermediaries, and personal relationships as a foundation for trust. And we see where that led, because when their law was faulty, it was exploited and they had no remedy in law. And they had to go and hack the entire system with a hard fork solution and split it with special favor. So let's look at the power imbalance, the users versus the code masters. In the technology world, many prefer to ignore the ways that software architecture grants the authority to shape behavior. The power of courts and regulatory agencies is easy to see, somewhat. That of code and its masters, less so. Yet both are power regulators. Poorly designed code can be as harmful as poorly designed law. That's from Werbach. While AI can help improve the detection of vulnerabilities in smart contracts, users must ultimately place their trust in a core group of coders and developers who design and build the architecture of the hyper-autonomous contracting systems. There's inevitably a power imbalance between users and these masters of the code, which may over time lead to distrust in the system. Vulnerabilities in the code, especially if they go undetected and result in incidents like the DAO attack, as well as the responses and actions of the core group of its coders and developers when they did that hard fork solution just to recover the funds for the ones that rightfully got deprived, it seems. That can exacerbate the distrust, because what was thought of as trustless, they find out that actually they can go in centrally and alter it. All right, and we're getting near the end here. As we get near the end, just remind everyone there will be a special treat at the end of this presentation, so make sure you stay to the end. Why did this slide go? There we go. Okay, so let's look at trust in law versus trust in code. Law has been viewed in political, economic, and social theory as crucial for the establishment of bonds of trust that underpin a market economy. As Collins explains, the regulation of contractual behavior by courts as agencies of the state provides a system of rules and sanctions that enables the necessary degree of trust between strangers to be constructed. That's the whole point of contractual behavior, trust between strangers. The rule of law has been widely heralded as a vital mechanism of social and economic order, with the law of contract playing a pivotal role in the legal system of a market economy. In the debates on AI and blockchain regulation, the rule of law is frequently pitched against the rule of code. The Philippi and Wright's thesis on lex cryptographia reflects this preoccupation. The architecture of hyper-autonomous contracting systems will present challenges to legal principles that regulate contractual relations, as well as the institutions that enforce legal rules and sanctions, courts. The courts may find that what parties had actually contracted was different from the terms of the smart contract, caused by code malfunctions or limitations of transposing legal contract terms into the language of code. Ooh. Let's move along here. The relational contract theory, the contracts in a social context. Again, these four modalities here. Relational contract scholarship offers new insights on the regulatory challenges in hyper-autonomous contracting by providing essential contextualization of contracting practices and norms. So, a common thread of relational contract theories is the view of contracts as being relationally constituted rather than merely discrete exchanges between parties. So relationally constituted. Remember, there's a value exchange, bargain for, all these different elements of a contract. And it's all built on relation and reciprocity and acknowledgement of certain aspects by both parties rather than merely discrete exchanges between the parties. They're related. As a preeminent theorist, Ian McNeill argues, an understanding of contracts as a social phenomenon recognizes that contracts are embedded in social structures and norms, not just law. This relational view may be contrasted with classical theories of contract law that focus on the express contractual agreement instead of the broader context of the parties' exchange. Remember, they don't all have to be expressed. They can be expressed or implied to be an actual contract. The role of the law or code may not necessarily be most important sources of trust or trustlessness that underpin traditional legal contracts or smart contracts in practice. Empirical assessment of day-to-day contractual behavior is essential. So again, you can see that even in the Uniform Commercial Code, that there's day-to-day contractual behavior that allows people that are engaged in those particular kinds of commerce would follow the Uniform Commercial Code rules and regulations, defining certain aspects of the elements of the contract, acceptance, consideration, things like that, based on the day-to-day behaviors in commerce and to keep the money moving, so to speak. So let's look at Macaulay's study of non-contractual relations. In his seminal work in 1963, Stuart Macaulay studied non-contractual relations in business exchanges. He defined a contract as a device for conducting exchanges with two elements. First, rational planning of the transaction to provide for a foreseeable contingencies, so dispute resolution, and second, legal sanctions to induce performance or compensate for non-performance. So, based on an empirical study of business exchanges in the manufacturing industry, Macaulay found that non contractual mechanisms, such as social norms and customs, played a more important role in ordering market exchanges than formal contracts. We saw here before the formal contracts are the ones that are dictated by statute, UCC, etc. Parties commonly entered into contracts for reasons besides legal enforceability. So that's another aspect. Once a contract was entered into, the adjustment of the business relationship and the settlement of disputes seldomly involved any contractual mechanisms or legal sanctions. Typically, people abide. Lawsuits for contractual breach were a rarity. Many business people chose to rely upon relational norms, including past dealings and industry customs, rather than opt for strict enforcement of the contractual terms if problems arose. So now we're seeing that code as law is not really the mainstay of contractual relations. Or business relations, I should say, are not necessarily contractual. And the paper deal versus the real deal. Macaulay later conducted an empirical study of how the paper deal, what is written in the contract, often differs from the real deal in contractual relationships. Yep. His findings included many instances the parties' subjective understanding of their agreement did not align with the written text of their contract. The parties assented to the terms and entered into the agreements that they had not read or would not have understood even if they had read them. Parties frequently provided oral assurances that contradicted or varied the written provisions in the contract. Sounds like every terms of service that anyone's ever used. Many business people chose to rely on relational norms behind the contract, including past dealings between the parties and industry customs, rather than opt for strict enforcement of the contractual terms if problems arose. And Collins had the three components of the real world contracting. Hugh Collins questions a conventional view that law of contract is a key component for establishing bonds of trust in a market economy. He argues that real world contracting consists of three components. One, the economic deal, the underlying commercial transaction that the parties seek to achieve. Two, the relationship, the interpersonal and business relationship between the contracting parties. Again, they could be strangers. So this is a developing relationship here. And then the formal contract, the written document embodying the parties' legal rights and obligations. According to Collins, when the parties enter into a contract, their behavior is usually not guided by a legal framework. Instead, their priority may be to sustain the business relationship and ensure that the deal is successful. Collins noted that firms use contracts as a form of insurance in case the business relationship broke down. So it's not the driving force, it's just there to back it up with legal rights and sanctions and a way to compel performance. So Levy says contracts as social resources. Karen Levy argues that the enthusiasm over smart contracts' features of self-execution and automated enforcement ignores the social norms and relational contexts surrounding contract practice. She considers the function of contracts as social resources used by people to manage their relationships. As she puts it, contracts are deeply social tools as well as legal ones. So contracts are deeply social tools. Levy represents or presents three types of contracting practices to illustrate the argument. So let's look at these three types of practices. Let's see here. One, unenforceable terms. Parties draft terms they know may not be enforceable to set norms and expectations. Two, vague or open-ended terms. Parties intentionally include imprecise terms, especially in long-term relationships. And three, intentional non-enforcement. Parties choose not to enforce contractual breaches to manage relationships. And see, smart contracts are hard and fast. There's no way to stop it if it decides to, and if the code is the law, the code says to do it, it's doing it. Each of these practices is examined in detail on the following slides. So let's look at the slide here, the unenforceable terms. The practice. First, parties may draft and accede to contractual terms that they know or suspect to be unenforceable before a court, such as clauses that are excessively broad or invalid due to a variety of reasons. As Levy explains, the main purpose of doing so is to set norms and expectations for each other's future behavior, including behavior that is beyond what is actually legally proscribed or behavior that's outside the reach of the formal contract. Which is interesting because, again, the contracts aren't there to enforce expectations, yet it's doing so to set the norms and expectations. She argues that these legally unenforceable clauses can serve a social function that is beneficial to either or both parties. Unenforceable clauses can serve a social function that's beneficial. Wow. So the purpose is setting norms and expectations for each other's future behavior. These are the reason for unenforceable terms. And implication for smart contracts? Well, smart contracts cannot encode terms that are intentionally unenforceable, since code, by its nature, executes all terms as written. Once put into action, it's going to execute. So here's number 2 here with Levy's practice, vague or open-ended terms. Second, the parties may intentionally draft or accede to purposely vague or open-ended terms, especially in long-term relationship. One common example is a duty on either or both parties to exercise their best endeavors to perform the contract. That's a burdensome specificity. Inclusion of more specific and defined terms would be unreasonably burdensome if the circumstances of the parties' agreement are likely to change in the near future. There's unofficial conduct. The parties may also prefer to conduct part of the transaction unofficially. Smart contracts wouldn't like that. Practice of vague or underspecified terms was often linked to the parties' anticipation or hope that their relationship would be a cooperative venture. And then trust preservation. Detailed and carefully negotiated contractual terms may obstruct progress in an exchange relationship and undermine parties' mutual trust. So interesting how this flexibility is part of trust and unofficial conduct and burdensome specificity. Well, let's look at Levy's practice number 3 here, the intentional non-enforcement. Third, the parties may decide not to enforce an agreement, such as overlooking breaches of contractual obligations by the other party. In some cases, the non-enforcement may be part of a behavior strategy to manage institutional and interpersonal relationships. Levy refers to the dynamic of bargaining in the shadow of the law. So what does this mean? It sounds slick, but when we talk about a shadow, it's not a force. The shadow is the absence of something. So it's bargaining in the absence of the law. Instead of pursuing formal enforcement of the contract, such as through litigation, the possibility or threat of legal enforcement can create a backdrop of social expectations against which extra-legal negotiations between the parties can take place. So Levy's core argument here is the social aims underpinning these practices, these 3 practices, include setting norms for future behavior, facilitating stable and flexible long-term relationships, and providing a strategic resource for bargaining in the shadow of the law. Enthusiasm for the transformative potential of smart contracts based on their careful pre-specification of terms and automated enforcement ignores the social complexities of contracting practices. So again, let's look at these 3 practices here. We have unenforceable terms, vague or open-ended terms, and intentional non-enforcement. All right, let's look at the, here we are. We're there. There we go. Recontextualization, the 4 interesting forces here. So again, we consider the 4 intersecting forces that have varying degrees. Again, the social norms, the parties' relationships, relational norms, past dealings, and industry customs, the market forces, the economic deal, supply and demand dynamics, and competitive pressures, the law, the formal legal rules, judicial interpretation, enforcement mechanism and remedies, and the code, the architecture of protocols and rules embedded in smart contracts and blockchain. Now, these forces coexist as mechanisms. These modalities are forces that support and maintain the necessary trust between people and create and sustain commercial relations. As Lessig pointed out, one modality may support or undermine another, and changes in one will affect the regulation of the whole. So by leaving social norms out, then it affects the whole regulation of the smart contracts. So as you see here, there's quite a few challenges here for us to pay attention to. Let's move along. Let's look at a commercial lease during COVID-19. Take a 10-year commercial lease as an example. Due to the adverse impacts of COVID-19 pandemic on her business, the tenant, who is 5 years into the lease, finds herself unable to pay the agreed rent on time during this period. The cost of renegotiating the existing contract or entering into a new contract with third parties, an example, the landlord tries to look for a new tenant or the tenant tries to find a more affordable option, is too high for either or both parties. The landlord and tenant may wish to maintain an ongoing stable relationship. Accordingly, the parties decide to have an agreement where the tenant is allowed to pay the rent late and the rent is reduced or even foregone altogether for a few months. Here, the landlord has intentionally chosen not to enforce the contractual term for a variety of reasons, including the cost of requiring performance or enforcement, the desire to maintain goodwill and preserve the relationship, and even fortifying mutual trust, not to mention the cost of getting a new tenant. In the above example, a smart contractor DAO set up to execute the rental payment on the fulfillment of predefined conditions. Example given here is payment is due on the first of each month, would not be able to offer parties such flexibility. Whoa. Now let's get Ripple versus R3 Consortium. Two of the most well-known blockchain companies, Ripple and R3 Consortium, still use traditional contracts for a deal in 2016 that gave R3 the option, we talk about option contracts, to purchase Ripple's cryptocurrency XRP in return for promoting Ripple's technology to R3's network of banks. Instead of specifying the number of banks to be introduced by R3, the technology promotion contract simply contained a clause that required both parties to act in good faith. In 2017, XRP's value unexpectedly jumped 20 times its original value when the parties entered into the deal. Ripple sought to unilaterally terminate the options contract, alleging R3 had not performed its obligations under the Parallel Technology Promotion Agreement and that R3 had misrepresented their ability and intent to deliver on their commitments. An ensuing lawsuit and counter lawsuit were filed in Delaware and Californian courts, respectively, by R3 and Ripple. The parties ultimately settled a year later. Whew, jeez. It's hard to envisage how hyper-autonomous smart contracting would have operated in respect of the R3 and Ripple's agreements, which reflect the complexity of real-world contracting practices. Yeah, like good faith. How do you quantify good faith? Such as the often intentional inclusion or vague, unspecified contractual terms. Ripple's claim of misrepresentation also illustrates a challenge of defects in consent or capacity. The law will still play an important role to correct the outcome of self-executed code. And ironically, that wasn't a smart contract that they had that dispute with. Now let's look at smart contracts as social resources. There should be a recontextualization of smart contracts to enable hyper-autonomous contracting systems to reach their potential. Recontextualization. We need to go beyond understanding smart contracts and AI contracting systems as merely technical artifacts devoid of broader social and relational context. There's a market, there's social context. Smart contracts should be viewed as social resources that could be used by people to manage their relations like traditional contracts. The rule of code, or lex cryptographia, is unlikely to replace other modes of regulation, even in hyper-autonomous contracting systems. Indeed, the trust in code cannot replace other sources of trust in business dealings, including interpersonal trust and institutional trust. The law will remain a necessary mode of regulation, serving as an important remedial institution that functions as insurance for parties to adjudicate grievances that may arise, even when smart contracts have fully executed the agreement. So we talked about executed contracts. Parties to a range of transactions may not seek frictionless self-execution of their agreements if there is a desire to maintain flexibility, preserve ongoing relationships, or set particular social or behavioral norms. So without that flexibility, they say that, the parts with the most flexibility can exert the most influence in a system. So without that flexibility, smart contracts will not be able to exert as much influence as traditional contracts. Now look at Collins' recontextualization of contract. Collins has suggested that for contract law to maintain its utility, it should be reconfigured to incorporate lessons from sociological and economic discourse of transacting in the marketplace. He argues, in seeking to pursue the objective of supporting contracts and markets, legal regulation should regard its task as one of protecting the expectations of the parties. This task requires legal regulation to examine the discrete agreement and embedded context of a business relation and market conventions, which is a process that we describe as recontextualizing contractual agreements. So that's the process, recontextualizing. For Collins, this recontextualization of contract entails open textured rules and interpretive strategies instead of a formal set of legal entitlements. Well, I wonder what that looks like. He argues that this is vital if the law is to provide effective support for the establishment of necessary trust and sanctions on which contracts and markets rest. In a similar vein, there should be a recontextualization of smart contracts which should enable hyper-autonomous contracting systems to reach their potential by recognizing the role of relationality in business transactions. A role that's unlikely to go away, highly unlikely, I'd say. All right, well, that takes us to our conclusion. Boy, this has been a long one, and salute to all you that have been able to stay here the whole time. Let's look at these key takeaways here. The integration of artificial intelligence with blockchain-based smart contracts is a rapidly emerging innovation with the potential to transform business and commercial transactions through hyper-autonomous contracting systems. But the hype associated with this frictionless and trustless automated transactions must be carefully scrutinized. Code alone is unlikely to be the sole mode of regulation, even in the most advanced contracting systems. Extending Lessig's theory of regulatory modalities as four modalities, a relational analysis of real-world contracting practices reveals the enduring importance of social context, interpersonal trust, and complexity of the parties' contractual behavior. So the market forces, social norms, and the law will continue to shape and constrain hyper-autonomous contracting systems alongside the code-based rules, the fourth force or modality. Future research must be empirical and interdisciplinary, involving law, computer science, economics, and sociology to study the real-world practices of hyper-autonomous contracting across the diverse types of business and commercial transactions. All right, well, for those of you that made it this far, we get to the best part of the presentation where we do the fun quiz. Let me explain how we do this. On the chat, you'll put in the number of the question you're answering here for question 1, and if I was going to pick letter D as my choice answer, I put in the chat Arabic number 1 followed by the letter D delta, and that would be my choice. If I decided to change it, I would put in the same number of the question again followed by my chosen choice. The last choice will be your final answer, and we'll tally up at the end and test your knowledge. Let's go. Question 1. A supplier and retailer have a smart contract for monthly deliveries. A natural disaster halts production, and the contract auto penalizes the supplier. He couldn't get the stuff there because of this natural disaster. What key limitation does this expose about the smart contracts? A. Smart contracts cannot verify real-world events without oracles. B. Smart contracts lack the social flexibility that traditional contracting practices allow. C. Smart contracts are inherently vulnerable to security exploits during crises. Or D. Blockchain networks slow down under high transaction loads during disasters. So, anyone in the chat there wants to take a stab at question 1. Supplier and retailer have a smart contract for monthly deliveries, but a natural disaster halts production for the seller here, and the contract auto penalizes that supplier because he wasn't delivering. What key limitation does it expose? Is it that the smart contracts cannot verify real-world events without the oracles? Or B, smart contracts lack the social flexibility that traditional contracting practices allow? Or C, smart contracts are inherently vulnerable to security exploits?
Carlos Enriquemero says, how to avoid identity theft within artificial intelligence used within smart contracts, social norms as per geolocation, and protect individual and personal assets when within one's own country. Debonaridez says 1, capital B.
Okay, we have one for 1B. That's a good answer. Let me just quickly briefly look at this. The chat here is how to avoid. Carlos says here how to avoid identity theft within artificial. Well, remember, this is being done with pseudonyms. So if your true identity isn't necessarily revealed through these smart contracts, and I guess that would be up to the user to determine what degree of anonymity or pseudonymity they can maintain. All right, so we had a answer here for question 1B. Any other stabs for question 1? We're going to move on to question 2, going once, going twice, on to question 2. A crop insurance smart contract uses an external weather service to trigger automatic payouts. So crop insurance smart contract uses an external weather service to trigger automatic payouts. So I guess insurance, when there's a weather event, hail destroyed all the crops, the external weather service would trigger the automatic payout for the insurance. The service reports faulty data, causing thousands in incorrect payments, so the farmers are happy. This scenario best illustrates which concept? A. The code is law principle means the payouts are valid regardless of data accuracy. B. Blockchain's immutability makes all on-chain errors permanent and irreversible. C. Trustless systems still depend on trusted intermediaries for off-chain data. Or D. All should replace human-operated data services to prevent, or AI should replace human-operated data services to prevent errors. So the service reports faulty data, and the scenario best illustrates which concept. So the service reporting faulty data, is it because the code means the payouts are valid? It illustrates which concept well. Is it that the blockchain's immutability makes all chain errors, on-chain errors, permanent and irreversible? Is it that the trustless systems still depend on trusted intermediaries for off-chain data? The service reports faulty data, or AI should replace human-operated data services to prevent errors? Any stabs for question 2? Crop insurance. We talked about insurance contracts. So there's an external oracle here, a weather service, sent a triggering events. It triggers automatic payouts, but it reported faulty data. So there's a hailstorm, there wasn't, caused thousands in incorrect payments. Do they have to return the payments? Probably not. But is that this scenario best illustrating which concept?
Carlos Enriquemero says 2B.
All right, we got one for 2B, that the blockchain's immutability.
Debonaridez says 2, capital A.
All right, and we have an A. So I think both of these are correct, but which one best illustrates the concept that reporting faulty data caused thousands in the incorrect payments? That's the real question here. So, all right, so we got our answers in. Let's move on to the next one. Anyone else?
Narrative says 2B.
Okay, we have it for 2B. Okay, so that's the final answer there. Indeed, errors are permanent, irreversible. Or is it because the trustless systems still depend on intermediaries for the off-chain data? We'll find out. Let's move on to the next one here. So question 3, 2 business partners sign a contract with an overly broad non-compete clause they both know a court would likely strike down. Why would rational parties deliberately include such a term? And some of our choices here. A, to trap the other party into an unfavorable legal position if their relationship sours. B, to signal expectations about loyalty and shape each other's future behavior. C, to satisfy regulatory requirements that mandate non-compete provisions. Or D, to increase the contract's perceived legal weight in case of dispute. All right, so we have some couple really good answers here, a couple ridiculous answers. Anyone wants to take a stab at question 3? 2 parties sign a contract, 2 business partners, and has an overly broad non-compete clause. They both know the court would likely strike down. But why would the rational parties deliberately include such a term, an overly broad clause that they know the court would likely strike down? Is it to trap the other party in an unfavorable legal position if the relationship sours? Is it B, to signal the expectations about loyalty and shape each other's future behavior? Is it to satisfy regulatory requirements that mandate non-compete provisions? Or D, to increase the contract's perceived legal weight in case of a dispute? All right, so we have a couple good selections here, a couple ridiculous distractors. Any stabs here for question 3? We have question 3 going once, going twice, going 3 times. Before we do this, I just noticed here, I don't know if it came up in the chat or not, but on question 2, wait a second. All right, I see Carlos changed to C, but for some reason it didn't show up in the chat here. Maybe it's because the asterisk at the end of it. You don't need to put the asterisk. Your last answer is always going to be the final answer, but I was able to see that outside the normal chat. I can't bring it on screen, but I see that you put 2 for C, which is the trustless systems still depend on intermediaries for off-chain data. All right. So question 3, do we have any takers for question 3? The 2 business partners sign a contract, overly broad, non-compete. Why would they do such a thing when they know the courts would likely strike it down? Was it to trap the other party in case of relationship sours? Was it to signal expectations about loyalty and shape each other's future behavior? Or was it to satisfy regulatory requirements that mandate non-compete provisions or to increase the contract's perceived legal weight in case of dispute? Legal weight. All right.
Narrative says 3, capital B.
3B. Okay, that sounds like a pretty good one there. And of course, that's acknowledging that social context, or that social force, I should say. All right, and to our final question now. Question 4. An automated lending platform smart contract instantly liquidates a borrower's collateral during a flash crash. Wow. Prices recover minutes later, but thousands have already lost assets. Which insight best applies? So it's an automated lending platform smart contract instantly liquidates borrower's collateral during a flash crash. Wow. Then the prices recover minutes later, but thousands have already lost their assets. Which insight best applies? Wow, so the smart contract liquidated was triggered by something. The platform should have used AI to predict and prevent flash crashes. That's A. B. Code-based rules alone are insufficient. Law, norms, and market context must also shape outcomes. C. Blockchain decentralization means no party can be held responsible for losses. Or D. Borrowers should have negotiated better terms before agreeing to the smart contract. So it's a little complicated. This is a difficult question, but it's an automated lending platform with smart contracts. It happens to liquidate all the borrower's collateral. So you deposit collateral, it lends money out. I guess it has some type of crowdfunding thing, but there's a flash crash and they had to liquidate all the collateral. But then the prices recover minutes later, but it's too late. They can't recover all lost assets. It shouldn't have been done. A human probably would have intervened and said, no, wait. But the smart contract instantly liquidates it on a flash crash. So which insight best applies in this situation? Should the platform have used AI to predict and prevent the flash crash? Could the code-based rules alone were insufficient? The law and norms must also shape the outcomes because they're relying only on the code-based rules. Was it because of blockchain decentralization means that no party can be held responsible? Which insight best applies? Or is it the borrower should have negotiated better terms before agreeing to the smart contract? Because obviously the terms were that the collateral could be liquidated instantly in a flash crash. So any takers for question 4? This is a difficult one, so just any guess would be good. Going once, going twice, going 3 times for question 4. All right, we're going to move on to the answers. This has been a long presentation.
Carlos Enriquimero says 4, capital C.
4C. We got a 4C. And let's just double check here. For 4C is blockchain means no party can be held responsible for losses. All right, let's look at our answers now.
Devin Eridaz says 4, capital B.
All right, we got a 4B there. Okay, so now we're down to the answer key. Let's see how well everyone did. On question 1, the supplier is auto-penalized after a natural disaster. Correct answer is B. Smart contracts lack the social flexibility that traditional contracting practices allow. So the traditional parties would renegotiate or waive penalties to preserve the relationship. Exactly the flexibility that smart contracts eliminate. So key one there is that I think we all get that one right there on number 1 for B for sure. All right, let's move on to question 2. The faulty weather data triggers the wrong insurance payout. Thousands lost. The trustless systems still depend on trusted intermediaries for the off-chain data. So the correct answer was C, the trust paradox. Blockchain removes some intermediaries, but shifts dependence to the oracles, whose reliability is critical. So it's not necessarily trustless, it shifts dependence or the trust to the external entities known as oracles. So that was a good one there for question 2. And I don't think anyone got that one right because that was a very tricky one there. Let's move on to question 3. Why include a non-compete that both parties know is unenforceable? And the correct answer is B, to signal expectation about loyalty and shape each other's future behavior. The unenforceable clauses serve a social norm, setting function, shaping behavior beyond what the law can formally enforce. So it's communicating. This is a signal here. Yes, it may not be enforceable by law, but it does signal expectations. Again, the expectations aren't necessarily expressed, so therefore this is why the flexibility is so essential in contractual relationships. And this takes us down to the final question, question 4. The automated lending platform does a automated liquidation during a flash crash. And the correct answer is B. The code-based rules alone are insufficient. Law, norms, and market context must also shape outcomes. It's not just the borrower's fault. And I think we get question 4, indeed. Got that one right there. So the illustrates the core recontextualization argument. All 4 regulatory modalities, not code alone, must govern contracting systems. So the contracting systems require all four regulatory modalities, not just the code, but the law, the social norms, and the market forces, the market context. Whew. Okay. Well, congratulations to all you that made it this far and went through this, because we're looking at some pretty high level, graduate level type of views on smart contracts and these hyper autonomous contracting systems as they are today. And the text we're reading from is just, it's, I think, 2022. So it's rather recent. A lot of these things have actually are into play right now. And it behooves us all.
Carlos Enriquemero says, question 3 seems biased, leaning more toward PNG, so to speak, to generalize or categorize a group of investors' frame of thought or thinking of supply and demand of product. S.
Oh, yeah, indeed. Let's look at question 3 here, just to the non-compete. So to speak, generalize a category, a group of investors' frame of thought for thinking of supply and demand of products. Indeed, they could expect some things to be delivered, expect something to be done at a particular time, knowing it may not necessarily be enforceable for that expectation, but at least to set it, knowing that it will be attempted in good faith. And if for some reason that the other party couldn't meet that obligation as intended, that they are still making the best effort to do it, and eventually would come to fruition, which would allow it to benefit that relationship and the resulting contracts. So yes, indeed, I could see a lot where you could see some of these larger corporations engaging in contractual terms that are like this, especially when you consider a large corporation can really do a legal onslaught that could be quite costly regardless of whether they win or not. So in that respect, you could kind of see where these terms would make a lot of sense. Yeah, they might ultimately not win, but if it was done in bad faith, they could definitely make it difficult for the counterparty there. So indeed, yes, thank you for that input. And I appreciate everyone that has attended here and has contributed into the comments and the commentary here and the feedback, because again, this is a ever evolving area of law and contracts and business and society. As we see, it's being integrated into every part. The most visible we see are these autonomous cars on the road, but now we're starting to see more of the smart contracts, payouts, insurance, crowdfunding.
Devin Eridaz says, thank you for the subtle comic relief. This is some really deep, thought-provoking information.
Oh, yes. Well, I thank you for appreciating that. And indeed, this is something that has come from comments here asking for more presentations on smart contracts. And this is the second one. The first one, we really got into some technical nuts and bolts. This is more of a overarching view of how smart contracts are intersecting with business, society, and the law, and where the computer code shows really where its deficiencies and strengths are through all of these interactions and transactions. And we can kind of see now how the real world interaction can never fully eliminate the need for trust. With that said, I thank you all for attending here, and I hope to see you all on the next one. Peace out.
Carlos Enriquemero says, in bad faith, so do blockchain angel investors do when brokers manipulate the pricing of stock or cryptocurrencies enough to wipe out retail investors.